There are objects hiding in the deepest images ever taken of space. They're smaller than a single star system, smaller than the gap between our sun and its nearest neighbor, and yet they're pumping out more energy than entire galaxies. Astronomers gave them a name that sounds almost cute: little red dots. Don't let the name fool you. These things have broken every model we had for how the universe grows up. They shouldn't exist. Not this early, not this bright, not this small. And after 3 years of staring at them, the people who study the sky for a living still don't agree on what they are. This is the story of the objects that shouldn't be there, and the terrifying possibility that they represent something no human being has ever seen before: a black hole, caught in the act of being born. In 2022, the James Webb Space Telescope opened its eye on the early universe for the first time. It was built to look further back in time than any instrument in history, and it delivered almost immediately. Buried in those first deep-field images, astronomers noticed something strange: tiny points of light, deep red, scattered across the frame like flecks of blood on a photograph. At first, nobody thought much of it. Red objects in deep space images are common. Distant light gets stretched and reddened on its way to us, a process called redshift. Red usually just means far away, but these dots weren't behaving like anything else out there. For one, there were a lot of them. Thousands. Once astronomers started counting systematically, they appeared consistently in a narrow slice of cosmic history, roughly 600 million to 1.5 billion years after the Big Bang. In cosmic terms, that's the universe's infancy. Toddler years. A period we'd barely been able to see before Webb existed. For another, they were absurdly compact. When astronomers measured the physical size of these objects, the number that came back was almost impossible to believe: roughly 100 light-years across. To put that in perspective, our own galaxy is about 100,000 light-years across. These little red dots are cramming galaxy-level brightness into a footprint 1,000 times smaller than the Milky Way. That's not a galaxy behaving normally. That's something squeezed into a space it has no business fitting into. So the search for an explanation began, and it did not go smoothly. The first guess was simple: maybe these are old galaxies, mature systems, full of aging stars, that somehow formed and evolved far faster than our models predicted. That idea collapsed almost immediately. A galaxy old enough to look like this would need to have assembled an enormous mass of stars in an impossibly short window of cosmic time, a timeline the standard model of galaxy formation simply doesn't allow. The math didn't work. Not even close. The second guess: dust-obscured supermassive black holes. Astronomers already knew that black holes feeding on gas, called active galactic nuclei, can glow intensely. If you wrap one in a thick shroud of dust, you'd expect to see exactly this kind of reddened light. This theory held on longer because it explained the color, but it ran into its own wall. Feeding black holes are loud. They blast out X-rays. They flicker and vary in brightness as material falls in unevenly. They often produce radio emissions. Little red dots do almost none of that. They're eerily quiet across most of the electromagnetic spectrum, and their brightness barely changes over time. A black hole that's actively gorging on gas is not supposed to behave this calmly. The third guess: maybe these are ultra-dense star clusters, not galaxies or black holes at all, just an extreme concentration of stars packed into a tiny volume. This one also struggled. The colors and brightness patterns didn't line up cleanly with what dense stellar populations should produce. And there was another detail nobody could explain with stars alone. When astronomers broke the light from these objects down into a spectrum, they found something odd: broad, V-shaped emission features, along with signs of hydrogen gas moving at velocities of several thousand kilometers per second. That kind of extreme, high-speed gas motion is a signature normally associated with material swirling violently near a black hole, not with a stellar population quietly aging in place. Three leading explanations. Three explanations that each broke against the evidence. By 2024, the little red dots had become one of the most talked about unsolved problems in astrophysics. Not because nobody had a guess, but because every guess failed a different test. Then, in 2025, a new idea started gaining serious traction, and it might be the strangest explanation yet. Researchers proposed that little red dots could be something astronomy has never directly observed before: black hole stars. Here's the concept. Picture a supermassive black hole in its earliest, most chaotic growth phase, buried at the center of an enormous envelope of extremely hot, dense hydrogen gas. Not a thin disk, not a wispy cloud, a thick, star-sized cocoon of gas, hundreds of times larger than the black hole itself, completely enclosing it. Inside that envelope, the black hole is doing what black holes do: pulling in matter, releasing enormous amounts of high-energy radiation as that matter compresses and heats up. Under normal circumstances, that radiation would blast outward as X-rays, easily detectable from across the universe. But in this model, the gas envelope is thick enough to trap that high-energy radiation inside. The X-rays get absorbed and reprocessed by the surrounding hydrogen before they can ever escape. The energy doesn't disappear. It gets converted, reworked, and eventually released as a steady, smooth glow of red light radiating from the outer surface of the gas cocoon. That single mechanism elegantly explains almost everything that had been so confusing. It explains the extreme compactness. The object isn't a spread-out galaxy. It's a dense gas envelope, wrapped tightly around one central point. It explains the missing X-rays. They're trapped and absorbed before they can reach us. It explains the lack of brightness flickering. The gas envelope smooths out the chaotic variability you'd normally see from a feeding black hole, because we're not looking directly at the black hole anymore. We're looking at glowing gas around it. It explains the strange V-shaped spectra and the fast-moving hydrogen. Both are consistent with dense, turbulent gas under extreme gravitational stress, close to a rapidly growing black hole. If this model holds up, little red dots aren't galaxies, and they aren't ordinary feeding black holes either. There's something in between, a transitional phase we've never caught on camera before. A supermassive black hole in its larval stage, actively gaining mass at an extraordinary rate, hidden inside its own furnace of gas. This matters for a much bigger reason than just solving one mystery. Astronomers have long struggled to explain how supermassive black holes, the kind that anchor galaxies like our own, manage to grow so massive so quickly after the Big Bang. The black hole star hypothesis offers a missing piece: an early, hidden growth phase where black holes could pack on enormous amounts of mass rapidly, shielded from view by the very gas that's feeding them. In other words, we may be looking directly at the childhood of the supermassive black holes that now sit at the centers of galaxies across the universe, including our own. The black hole star idea is currently the leading hypothesis, but it isn't the only one still standing, and the scientific community hasn't closed the case. One alternative points to population 3 stars, the theorized first generation of stars to ever form in the universe, made purely from hydrogen and helium, with none of the heavier elements later generations of stars would contain. These stars are predicted to have been enormous, extremely hot, and extremely short-lived. Some researchers argue that dense, compact clusters of these primordial giants could reproduce at least some of the observed light patterns, though this explanation still struggles with the object sizes and gas velocities. A second alternative involves direct collapse black holes, a theoretical pathway where a massive cloud of gas collapses straight into a black hole without ever going through a stellar phase first. This would let black holes reach large masses almost instantly in the early universe, potentially bypassing the slow, star-by-star growth process entirely. A third alternative looks not at the objects themselves, but at their surroundings. Some researchers propose that little red dots could form inside rare, low-spin dark matter halos, pockets of dark matter that, due to their unusually slow rotation, allow ordinary matter to collapse into unusually small, unusually dense galaxies. Under this model, the little red dots wouldn't need an exotic black hole mechanism at all, just an unusual cosmic environment that concentrates ordinary galaxy formation into a tighter package than normal. Each of these ideas has defenders. Each has weaknesses. And as of now, none of them has been proven, including the black hole star model. Here's the uncomfortable truth. We still don't know exactly what the little red dots are. We have a leading hypothesis with real explanatory power, a handful of serious competitors, and thousands of these compact red objects scattered across Webb's deepest images, waiting to be understood. What we do know is this. The early universe was not the calm, orderly nursery scientists once pictured. It was violent, fast, and strange, capable of producing objects that break the rules we built from decades of studying the nearby cosmos. Every little red dot Webb finds is a data point in an ongoing investigation, one that's actively rewriting how supermassive black holes are born, and how quickly the universe was capable of building extreme structures right out of the cosmic dark ages. The mystery isn't solved, but it's one of the most important open questions in modern astronomy, and the answer, whenever it arrives, is going to change how we understand the beginning of everything. If this is the kind of mystery that keeps you up wondering what else is hiding in Webb's data, subscribe. This channel is dedicated to tracking the biggest unanswered questions in space as they unfold in real time. Drop your own theory in the comments. Black hole star, primordial star cluster, or something we haven't even considered yet? I read every one. And if you want to go deeper into how supermassive black holes grow, there's another video linked right here that picks up exactly where this one leaves off.